25,000 years ago, a single bad decision about firewood could kill an entire family by morning. Not a war. Not a predator, just cold. The temperature outside a mammoth bone shelter in what is now Ukraine could drop to -40 degrees Celsius. Inside, with the fire tended right, it stayed above freezing. That gap between -40 and just above zero was the entire margin between a family that woke up and a family that didn't. We think of the Ice Age as something that happened to animals, woolly mammoths, cave bears, saber-toothed cat, but it also happened to us. Homo sapiens spent tens of thousands of years living through winters more brutal than almost anywhere on Earth today. And they didn't just survive them, they thrived through them, generation after generation, without insulated jackets, without central heating, without so much as a zipper. How? The answer isn't toughness. It's technology, fat, and each other. Let's start with fire, because fire changed everything. Archaeologists have found evidence of controlled fire use going back over 1 million years. But true mastery fire you could carry, protect, and rely on through a 6-month winter is a much more recent human achievement. At sites like Cavemen in France, dated to roughly 12,000 years ago, researchers found hearths positioned with obsessive precision, not random campfires. Engineered heat. Reindeer hunting groups built their shelters around these hearths in specific patterns, angling entrances away from prevailing winds, banking snow against outer walls for insulation. This wasn't instinct, this was architecture. And fire did more than warm bodies. It cooked meat, which made calories easier to absorb. It hardened wooden spear tips. It kept predators at bay through the darkest, hungriest months. Losing your fire in January wasn't an inconvenience, it was a death sentence. So how do you keep a fire alive for months in a landscape with no matches, no lighters, and no guarantee of dry wood? You never let it go out. Ethnographic accounts from cold climate hunter-gatherer societies, including groups in Siberia and the subarctic, describe fire as something transported, not restarted smoldering embers carried in pouches or slow-burning fungus, kept alive through travel so a new blaze could always be struck from an existing coal. Fire wasn't just a tool, it was a lineage, a flame handed down. But fire alone doesn't explain how humans handled cold that could kill an exposed person in under an hour. For that, we need to talk about clothing, and specifically about a hole. Around 30,000 years ago, someone invented the eyed needle. Not an awl for punching leather, a needle with a hole for thread. Archaeologists have recovered bone needles from this period at sites across Russia and Central Europe, and the discovery reshaped how researchers think about Ice Age survival. Because an eyed needle doesn't just let you wrap yourself in a hide, it lets you tailor. Tailored clothing is fitted. It traps warm air against skin instead of letting it escape through gaps. Genetic research on human lice. Yes, lice has actually helped pin down when humans started wearing clothes. At all. Body lice, which live in fabric rather than hair, appear to have evolved as a distinct species roughly 170,000 years ago, suggesting that's roughly when humans began regularly covering their bodies. Isn't it strange that a parasite helped solve one of archaeology's biggest mysteries? By the depths of the last ice age, humans in Europe and Siberia were likely wearing layered, fitted garments, inner layers for insulation, outer layers for wind and water resistance, hoods, boots stuffed with dry grass for warmth. Some reconstructions, based on burial goods at sites like Sungir in Russia, suggest incredibly sophisticated outfits, thousands of ivory beads once sewn onto clothing in patterns that took hundreds of hours to create. That's not just survival gear, that's status, that's identity. Even while freezing, humans were dressing to be seen. Now here's where it gets personal, because your body still remembers this era, even if you've never spent a night below freezing. Cold climate populations show measurable biological adaptations. Some Arctic and subarctic groups today carry genetic variants linked to enhanced brown fat activity, the kind of fat tissue that burns energy specifically to generate heat rather than store it. Researchers studying indigenous Siberian populations, including the Yakut, have found metabolic and body composition differences that appear shaped by generations of extreme cold exposure. Your ancestors didn't just adapt behavior. In some populations, cold adapted the body itself. And then there's fat, ordinary body fat, which mattered more during an ice age winter than almost any other resource. A body with insufficient fat reserves loses the ability to regulate its own temperature. Pregnant and nursing women faced this danger most acutely, needing enough stored energy to support both their own survival and a developing child through months when food was scarce and unpredictable. Some researchers have proposed this is part of why human females across almost almost all populations, carry a higher percentage of body fat than males of similar fitness. Not simply reproduction, but climate insurance. A buffer against a season that could kill. Doesn't it change how you see a body, knowing it might carry the memory of 10,000 winters? But even fire, clothing, and fat weren't enough on their own. The real technology that got humans through the deadliest winters wasn't a tool at all. It was each other. Anthropologist Robert Kelly, among others studying hunter-gatherer survival strategies, has pointed to social cooperation as possibly the single greatest human adaptation to environmental extremes. Small, isolated families rarely survived Ice Age winters. Large, interconnected social networks did. Groups shared food when one hunt failed and another succeeded. They shared shelter space, body heat, childcare. Knowledge which plants were edible, which route through a valley avoided the worst winds, which signs in the sky meant a storm was 2 days out instead of 2 hours. A study of forager societies found that individuals maintained wide social ties across dozens or even hundreds of kilometers, creating a kind of insurance network. If your group's hunt failed, you could travel to a related group whose hunt had succeeded, and they were obligated, by deep social custom, to share. This is why isolation was so dangerous. Not just emotionally, biologically. A human alone in an Ice Age winter was a human without a backup plan, which raises an uncomfortable question. If cooperation was the thing standing between our ancestors and death by freezing, why do modern humans still treat isolation like an inconvenience instead of a threat? Maybe because we've forgotten what our bodies still remember. Every layer of clothing you own has an ancestor made of stitched hide and a bone needle. Every furnace or radiator in your home has an ancestor in a hearth carried across a frozen valley as a single glowing coal. Every emergency contact in your phone has an ancestor in a hunting group 2 valleys over, obligated by custom to take you in if your fire went out. The deadliest winters in human history didn't just test our ancestors. They built us. They shaped our metabolism, our social instincts, our need to belong to a group larger than our own household. You will probably never face a winter that could kill you in an hour. But somewhere in your biology, in your craving for warmth and closeness when the temperature drops, there's a 25,000-year-old memory still running in the background. It's not asking you to survive anymore. It's just asking you to remember that you're not supposed to face the cold alone.